Hi, system design of rate limiting is really interesting, and today I was having this discussion with one of my friends, and I thought of sharing this with you. So, normally when you design a rate limit, you want to rate limit on basis of IP or maybe rate limit on basis of API key. But there is very interesting scenario with rate limiting that will challenge your mathematical skills, I will say. And if you're good with mathematical puzzles, etc., you might be able to guess the issues I will propose with the design of rate limit at first. So normally when someone designs a rate limit, he will think, okay, I want to rate limit on basis of IP for 60 seconds, probably in 1 minute maybe. And let's assume you want to rate limit a user based on a minute, and you want to allow like 10 requests per minute. So I have a question for you. How many requests do you think that a user can make at max in 2 second of interval? So I'm seeing like a user has like 2 second of interval in the whole day in 24 hours. How many requests a user can make in like how many max requests a user can make in 2 seconds? If your answer is 10, then I have a very simple or interesting thing for you. So let's assume a user makes 10 requests at 59th second. So if you guessed it, then that's great. But if you think that a user can make max 10 requests only in 2 seconds, then you are wrong. User can make 10 requests in the 59th second, and user can also make 10 requests in first second. So you might ask why this is a problem. I don't care if user makes 10 requests in 59 second or 10 requests in the next 1 second of interval. I wanted my user to be limited on the basis of a minute. But the issue is when you have systems based on rate limiting, you are getting 2x of spike which you intended at max to have from the user's API key or IP. It is completely fine that user is able to request 10 in a minute. The issue is not that. The issue is user is able to make 20 requests in 2 seconds. And that is a sudden spike on your service that can at a very hard scale can make your service port restart, because HTTP connections or TCP connections uses memories a lot. So what's the solution for this? What I can do to solve this problem? So this was the first solution which we might have thought about designing the rate limiter. I told you about the issue that this has the issue of getting burst at boundary, and of course burst at boundary is very big issue, and that can make your ports restart and application go down at a sudden instance. So what is a better solution? If you are good with lead code and all, then you might be hearing of this thing called sliding window. We can use a sliding window and have a window to maintain, probably I will say, timestamps like 1 second time with something like this, or probably a DQ if you guys are aware about DQ. This ID is nothing but IP. Let's assume this is IP in this case. ID can be API key as well or something. So let's assume that we are storing key value pair of IP and request timestamp made. These are nothing but request. So user made a request on first of second with this IP. A user made a second on the second user made another request. So this way what we're gonna do, like when we are at the 59th minute and we come to first, when we are at the 59th second and we come at the first, what we can do is we can use sliding window, and simply we can just remove the we can just pick the 69th of second. Probably let me throw this. So we'll just pick the last 60 second, not the interval. So we don't have a fixed window, we have a sliding window. Our window is just sliding and getting here, and this is getting skipped. So technically I can only make certain number of requests in the last 60 second of time frame, not in the 59th or in the first second. So I avoid that issue of sudden burst. So I hope you guys understood this sliding window approach. We are doing nothing, we just sliding a window from the first second to next and next and next, making sure that we have the current 60-second window size, not the a fixed window size of 60 seconds. So this sounds a good problem. I mean, in lead code we use sliding window a lot, so this might be great problem. That's why we study it in data structures and algorithms, right? No, actually no. The reason why this is not perfect, if you guessed it, then that's great. If you didn't, then you didn't see the time complexity or space complexity here. I'm maintaining a n size of map, and for a 60-second interval it might seem fine, but we will have like thousand of IPs. We might have thousand of IPs, and I'm just saying thousand, that's very small number when we compare it to very big applications. That is a big issue. We have like thousand maps. I mean, this is a big n size complexity, and this is a big issue, and this can cause a lot of memory spikes. We are maintaining huge data structure in our memory. Although this was a very good fix, but it was not very optimal. We needed a better solution, and a solution that not only makes my spikes go away, but also is a very simple data structure to maintain. So this is the solution, which is a solution. Alright, so I'm gonna explain this approach about which is a token bucket approach, and this approach is used by many big companies, like I think Stripe uses this, or many other companies uses this for rate limiting approach. So what we do is we maintain a bucket of tokens, and these tokens are nothing but requests. So if I have 10 tokens, this means I have 10 requests. So I will add it here, like these are nothing but requests. So I have like 10 requests in a bucket allowed. The reason for that is because this bucket does not get filled instantaneously. It gets filled with a certain rate and a certain algorithm. So for example, let's assume that we have 10 max requests allowed in a minute. So we can have a rate of something called 1 by 6, where I let my bucket get filled in the 6 seconds interval. So my bucket will get filled with one token in the 6th second of next interval, one request in the 6th second of next interval. So user can make, I think, 11 requests in 7 seconds, but that is way better than 20 requests in 2 seconds. This way user can also make second request in only 12th second of next interval. So my first token will get consumed here, and my bucket will get filled one with a token again. And similarly, this will get filled with 8 tokens if I don't use it, and I can have like 8 tokens at the 59th second. I can make 8 requests. So you see how this whole approach fixes the issue of 2-second sudden spike. So with this approach, you saw how I can make my service spike free with my rate limiting algorithm. I can use this to avoid the heavy data structure management of n size, which I had with sliding window. So I couldn't use sliding window in a very scalable scenario. I couldn't use fixed window because I experienced a spike there at the boundaries. But I can use this approach where I just don't fill the bucket instantaneously. I use a rate limit. I use a rate at which this bucket gets filled up. And for more cool system design and software architecture videos, do subscribe, like the video if you liked it. Thank you so much. I will see you in the next video.